Solve cosine of the quantity 2x minus pi thirds equals negative square root 3 over 2, finding exact solutions in the interval from 0 to 2 pi. All right, the first thing I'm going to do is I'm going to take this stuff that's in the parentheses and I'm just going to call that theta. So I have cosine of theta equals negative square root 3 over 2. So I'm interested where the cosine is negative square root 3 over 2. So I know cosine is negative in quadrants 2 and 3. And square root 3 over 2 is the larger for the x. So that's going to be here and here at 5 pi sixths and at 7 pi sixths. So if I wrote down those solutions, theta equals 5 pi sixths or theta equals 7 pi sixths. If I wanted to get all solutions, I would say plus 2 pi k for both of those. And now what I'm going to do is I'm going to replace the theta with what it equaled here, which was 2x minus pi thirds. I think in the interest of room on this, I'm just going to erase the thetas and put in 2x minus pi thirds on both of these, 2x minus pi thirds. Now what I want to do is I want to do the algebra to solve for x. So I'm going to add pi thirds to both sides. And if I put a plus pi thirds here, actually I'm going to change that. Instead of writing pi thirds, I'm going to write plus 2 pi sixths, make the pi thirds into 6 so I can combine it with the 5 pi sixths. And so that will make this side 7 pi 6 plus 2 pi k. Now the last thing I need to do here, I got rid of this, but I've still got a 2 in front. And so I would need to divide by 2, and I would have to divide this by 2 and this by 2. So let's rewrite it down below so we can see what we have. So if I divided by 2, I would have x equal, I combined those and had 7 pi 6 times the 2 would make that 12 plus pi k. What that would do would give me half of the solutions, the ones that came from that original angle, by adding or subtracting various multiples of pi. Now I am interested in just finding the ones between 0 and 2 pi, so I'm going to write the first one, which would be if this k was 0. So 7 pi twelfths is the first one. Now I'm going to go to this second equation and I'm going to solve this one for x, much the same way as I solved the last one. And so I am going to add pi thirds. So that'll cancel and I'll add it over here, but I'll write it as 2 pi sixths so that I could combine those. And so let's go ahead and combine those. 7 and 2 makes 9 pi sixths plus 2 pi k. And then that last step I did was divide by the 2. And I would need to divide by 2 over here and by 2 over here. I guess technically I should have done this to the middle ones as well. I'm working with that and. All right, let's write down what that one leaves us. It leaves us x equal 9 pi twelfths plus pi k. Now 9 pi twelfths will reduce by 3. I'm going to put that as my second answer, but 3 will go into the top 3 times and it'll go into the bottom 4 times, so 3 pi fourths. So there are 2 of my solutions. Now I got the graph here so we could see what was going on. Essentially, if we look back at our original equation up here at the top, we have on this left-hand side cosine is 2x minus pi thirds. Okay, we have a phase shift. The phase shift would be pi thirds divided by 2, or pi sixths. So we look on this graph and we can see that this is moved to the right by pi 6. And then also because of the 2 on the x, the period is pi. So as we look at this graph, it cycles in pi. And so by the time you get over to 2 pi, which is right here, between 0 and 2 pi, this red line is down at negative square root 3 over 2, and you can see that there are 1, 2, 3, 4 solutions. And that's how many I would expect if the period is pi, because it would do 2 cycles by the time it got to 2 pi, and I get 2 solutions for each of those cycles. So I need to get 2 more answers. And so to get my next solution, I'm going to go back to this one and let the k be 1. So I'm going to add pi to this, which is adding a period to this to get the next one. Okay, well, if I add pi, in order to add it to 12, I just need to make it into 12ths. So 12 pi 12ths. So I'm going to add that to the 7 pi 12ths and get my third solution, which is going to be 19 pi 12ths. And then to get my fourth solution, I'm going to come over here to the solution I had, and I need to add pi to it. Now we reduced it to 3 pi fourths, so we could add pi to that, and when we add pi to that, we are going to get, well, 4 pi fourths plus 3 pi fourths. It looks like we are going to get 7 pi fourths. So there are my 4 answers that I would expect here. So if it's a cosine or a sine and it's got a 2 in front of it, I'd expect 4 answers. The thing I got to be careful about is this graph has a phase shift, and if by chance in the phase shift this last solution would have moved over here past 2 pi, then it also means one of the solutions that was here negative will move over here into the positive. So a graph kind of helps me see, but because I was able to find 4 solutions and the fourth one was still less than 2 pi, I'm in good shape. If the fourth one would have been greater than 2 pi, then I would have gone back and picked a solution that was minus pi away, and by the time I had done that phase shift, I would be on that interval. So we're good with the 4 solutions just like this.